Lesson 1.9, limits of rational functions. You should remember that a rational function is just some kind of polynomial over a polynomial, so it's a fraction. And there's three different things that could happen. The easiest one is its direct substitution. That means that I'm going to find what is the limit as x approaches -5. I'm just going to plug in -5 and see what value is there. So let's try that. We would have -5 squared minus 1 over -3 times -5 plus 3 be 25 minus 1 over 15 plus 3. Simplify that, so I would divide out what, a 6? Yep, and that would be 4/3. So when I get a number over a number, that is going to be the solution. Here's the graph of it. I'm looking at -5, which is right here. Let's see if I can pull up a point. I saw it for just a brief moment. Ooh. It's 1.3 repeating, which is the 4/3 or 1 1/3. So that is correct. There was no problems with having a piecewise where you've got to jump. Everything's good. So I always do that first. Let's try that on the second one. I'm going to plug in 7. So I have 7 squared minus 6 times 7 minus 7 over -2 times 7 plus 14. And I'll just tell you that you get 0 over 0. You can check it if you don't believe me. What that is called is indeterminate form. That means you can't determine it. You can't determine what's happening to it yet. You have to factor it. So I'm going to take this top polynomial. This is a basic trinomial. And I'm going to factor. I'm going to have x times an x. What two numbers multiply to make -7 that add to make -6? That would be -7 and +1. And on the bottom, I can factor out a -2 to have x minus 7. So do you see a factor that cancels? Yeah. And I'm hoping you remember that back from rational functions, we always try to factor, and if something cancels, that means there's a hole there. And that hole is at 7, which is why we're having the issue in the first place, is because we're trying to evaluate the limit at 7. So what you want to do is now write what part of your function is left, x plus 1 over -2. We're going to find the limit as x approaches 7 of this guy. So that would be a 7 plus 1 over -2, which would be 8 divided by -2, which should be -4. And let me graph it real quick and I'll show you. Here's my function. It ends up being a straight line. If I zoom in, because we were looking at 7, which would be right in here, you can see that it's at -4. And when I look at 7, it says undefined. That's because that was our hole, but you can see from 6 to 8, you can see that it's -3.5, -4.5. That -4 is right in between there. Okay, and then the last thing that could happen is you get a number over 0. So I would try direct substitution first. That would be 0 squared plus 9 times 0 plus 14, which 0, 0, I don't know why I have that there, plus 14 would be 14. And then this would get 0 squared plus 3 times 0. So that's 0. That tells me right then and there that that does not exist automatically. And the reason why is because we're supposed to factor this. Okay, so let's say we have x plus 7, x plus 2, over, take out an x, that'd be an x plus 3. Nothing cancels, there's no holes, but my asymptotes, my vertical asymptotes come from where the denominator is 0. So that would be here at x is 0 and here at x is -3. Well, we're trying to find the limit when x approaches 0. There's an asymptote there. So of course the limit is not going to exist. Let me show you that graph real quick. You can see right here when x is 0, you can see that there's an asymptote right here.